Well, we have beauty and humor on the podium, so we're having a good time. We're going to do questions now, and I'd like to ask the panel a question. I've always been confused by the ambivalence that all the experts have about whether warming, if it did occur, would produce droughts or floods. It's my basic understanding that if you warm up the planet, you're going to evaporate more water out of the oceans and create more precipitation as a general rule. And I'm wondering, am I just demonstrating that I'm an ignorant person when I assume that warming will produce water, which in Texas is a precious thing, coming out of the sky it is.
The general circulation models actually suggest huge variability for any single location in terms of whether there's going to be more rain or less rain. Quite extraordinary the extent to which, say for central Queensland, they can vary in their predictions. So what the general circulation model people do is they take an ensemble value which tends to often suggest a slight decrease in rainfall. If you run an artificial neural network, as we have done for example, for Nebo in central Queensland, under the scenario of a 3-degree increase in temperature, what you get is actually a smoothing in the annual variability. And Nebo is a place that has tremendous summer rain and very little winter rain. And what we find with the neural network is that you get a smoothing, so you get less summer rain and a little bit more winter rain, which would not be bad for that part of the world.
Well, that smoothing effect is something that I've seen in terms of the research on what the effect of warming is going to be for the temperature of the globe at night, at the higher latitudes, and all that other stuff. So that makes sense. Do either you, Dr. Morner, or Dr. Fred, would you be willing to comment on whether warming is going to produce a significant or a trivial increase in precipitation?
No, I think it was so beautifully said, so why should I compete with that? But one thing which one can say, which is interesting and takes you back to sea level. Sea is controlled by many factors. One is gravity, that you call the geoid, and sea level should approximate it. For a lot of dynamic reason, it can depart from it. In the Indian Ocean, where we have the highest rate of evaporation, sea level is about 30-40 centimeters below the equipotential surface. That's very interesting. That's because of the evaporation. That was one of the interests when I went to the Maldives, where I wanted to check these things, because theoretically, if you increase the heating, you could even say that more evaporation, sea level would lower locally, of course, in that area, and more moist into the air. But this is a complex system. We just brought you back to sea level, because that's yeah.
I guess adding there, and I guess importantly for people into the future, looking at sea level, looking at Antarctic increase in polar ice, what you will tend to see, and looking at the natural cycles, if, as it appears, we're going into a cooling period, for the areas of Australia that I'm familiar with, you would expect to have a significant decrease in rainfall. So, for example, you would expect, and I think we are looking at a drier future for the next 10 to 30 years, which I think should be of concern and is something that we should be planning for. So actually, while there is not, in an Australian context, agreement about whether the future is going to be cooler or warmer, I actually think there is agreement that for Australia at least, the future is likely to be drier.
Dr. Singer?
Yeah. Let me make one comment here, which is sort of interesting. There is agreement, believe it or not, among people that there was some warming in the early part of the 20th century, between 1910 and 1940. It used to be believed by some people that this was due to human effects, but it is now disregarded. IPCC no longer believes it. In their first report, this is what they believed. In the second report, they no longer accepted that. In subsequent reports, no longer accept that. So it was a genuine warming, but due to natural causes, likely the sun. Anyway, during this warming period, the sea level rise did not increase. In fact, it decreased slightly. This has been noted, but nothing much has been made of it. It's an important fact, because many people assume that if there's a rise in temperature, there will also be a rise in sea level. Not at all, just the opposite. And the point is, as Nicholas has mentioned, evaporation. But evaporation with subsequent deposition of the water vapor as ice in the Antarctic, on the Antarctic continent. So it's the Antarctic continent that receives the water vapor and turns it into ice, and therefore essentially ocean water turns into ice, and therefore there is some drop in sea level. In fact, you can see it in the record. There's a slight drop in the rate of rise of sea level between 1920 and 1940. And that was noted and remarked on even 20 years ago. Now, to explain it all, one needs to have data on the rate of accumulation of ice in the Antarctic. That data is very hard to come by. But it now exists, finally, after 20 years, and with the data in hand, we can now publish this work as being reasonably sure. Then the interesting question is, what if the rise in sea level is offset by evaporation and subsequent accumulation of ice? What really causes the rate of sea level rise? And the answer is slow melting of ice in the Antarctic. By slow melting, I mean melting that extends over millennia, not melting that extends over decades, but slow melting over millennia. Ice, as Nicholas has remarked, has a very long memory and melts very, very slowly, particularly in the Antarctic, where temperatures are extremely low. And even ocean temperatures are very low, so that melting is a very, very slow process. And in fact, the data support this hypothesis, because we have geologic data on how ice is disappearing in the Antarctic, and it is disappearing at a very, very slow rate, that is over millennia, not very fast at all. Do you want to make it?
Well, I'm stunned by the brilliance of you three. This is amazing. Anyway, I can't see anything because of that bright light, so whoever's handling the mic, find your people and let them talk.
Yes.
Questions, please, though.
Dr. Morner and Dr. Singer, each of you in your presentation talked about the satellite altimetry data, and you mentioned that there's potential problems with with that data set. Would you care to share with us some of those main biases that you see?
Yes. Could I have my...
That mic.
Would it be possible to get my slides back? Thank you. Satellite altimetry. Let me... Do you get the slides back?
One second.
Here. Okay. Okay, back one. Satellite altimetry. That is how it was first published. First publication in 2000. You can see it's a straight line, and there is a possible rise, the blue line, of 0.7 millimeter per year. But that's influenced by the ENSO event, and you shouldn't include ENSO. ENSO has nothing to do with long time. So if you make it better, as I did here, this is a straight line, ENSO sitting on it, and here it becomes very complex. Next time we hear it, it's in 2000 Aviso, then the whole data set, including this one, have become tilted by 2.3. That is not a measure. It's a human action to tilt it. Okay? And we don't go for that. And why did they tilt it? Because they had the Peltier's idea of we must compensate for glacial ice used as all over the globe, which upsets the principle of Archimedes, by the way. I need physics, he didn't need it. So in Hong Kong, his zero isobase happened to pass. So he said, wow, then I can go there and check what sea level. They had 6 tide gauge stations. He selected one, which had a rise of 2.3 millimeter. And they say, wow, we have it all. The equation is closed. But that's the only tide gauge station with all geologists say it's subsiding. So the all 1 to 5, and that's the background. The next time we see it, it is going up by 3.2. It's double what the tide gauge is saying. But note here that it's a red line. That is the gravity study, GRACE. But GRACE, that is after calibration. If you go with the reading was here. So if I tilt that down, this one makes sense for the first reading of which I just have shown you. And this makes sense with the GRACE. And all the tilt is artificial. So what you have is satellite reading, it must be technically adjusted, and then you get 0 about. Because and when you make your personal adjustment, you get up to this. So this one, it's not written anywhere that it's after calibration. And I mean, in science you can do all kind of calibration, but you have to specify it. If you don't specify it, you are fiddling. Okay? So that's the background. Sorry.
Very good. Very good.
Another example of cherry picking for an agenda. Next.
Dr. Marohasy, you mentioned that your neural network seemed to imply some drying in central Queensland over the next decade. Can you generalize that to California and Texas, for example?
You're not allowed to talk about drought in Texas at this meeting.
I guess just a point of clarification, the neural network that we have developed that we're using at the moment can only forecast 3 months, so we do monthly rainfall to 3 months in advance for localities in Queensland. But if you look at the longer term cycles and the forecasts from the people who use planetary and lunar cycles, some of them will go out 16 years, they are forecasting drought for Eastern Australia. Yeah.
Next. I'm still blinded, so I don't even know where you are with your mic. Go ahead.
From a non-scientist, on landfall, can rainfall on specific local areas be affected by a large number of installed wind turbines?
Perhaps I have not seen the technical literature on that, and I've not thought about it from a physical sciences perspective.
Another question back here.
I have a question, 2 questions. One is, I observed a lot of deserts on this earth, and then in each continent, say Asia, say China, the east part tend to be green area and the west tend to be desert. And then I come here in Nevada, and this is the west, and it's also dry, and I have been living in Boston, is east, and we have a lot of rain there. So this is number one. And my mind keep on thinking, the earth is spinning from west to east. Does this have anything to do with the earth moving and the west part and the east part dry and wet? This is number one. Number two, I just made a trip to Grand Canyon, and the Grand Canyon, the view, the pilot told me is a result of 40 million years of the river erosion. So my question is the Grand Canyon growing up from the earth, or the water is going down as a result? Thank you.
You say something, I can say something after.
I guess what's important to recognise is that there is a lot of regional variation in rainfall, and it's affected by topography, local topography, and latitude. So it is actually difficult to generalise, though geographers may be keener than I am to generalise as such. With respect to the Grand Canyon, I can't answer that question.
I can add something to your east-west variations, because that, for me, that is very important, because it has to do with the ocean surface circulation. And the surface circulation is in very strictly controlled by the Earth rate of rotation in the short term and the longer term. I take one example. During the during the medieval warm optimum, it was warmer in many places of the world, and the rotation was upset. We had a higher sea level in Europe. We had a higher sea level in East Africa, but we had a low sea level in Peru. 100 years after, 50 years after, it switched it. So it get a low in Africa and a high in Peru. And all the Inca fantastic irrigation system broke down. And in Sweden, in Northern Europe. But that is the surface, and that brings, of course, energy. And I think this is something very, very important to explore. And for me, it is controlled ultimately by the planetary beat on the sun, and the sun's not at all the luminosity, it has nothing to do with it, but this solar wind hitting and taking care of the Earth rate of rotation, and a lot of other factors. So they've written a lot of it. You can get it in the papers.
Dr. Singer, you spoke of a melting of ice in Antarctica. Are you referring to the entire continent or just the West Antarctic ice sheet?
I think.
When you talk about ice sheets, are you talking about the West?
Decreasing ice in Antarctica. Do you mean the entire or just the part?
No, not the entire. The geologic evidence deals with the Ross Sea, and published in about 10 years ago in Science magazine, and you can see the recession of the ice. This is an ice sheet. This is not floating ice. You can see the movement of the grounding line over millennia. And that's been measured, and I think one can calculate from this, and I've tried to calculate from this, the rate of loss of ice from the Antarctic, from ice sheets. It's entirely in the West Antarctic ice sheet. It is not in the East Antarctic ice sheet at all.
Okay, this will be the last question.
For Dr. Morner, I understand, sir, you're from Stockholm.
Yes.
And you are undoubtedly familiar with the Nobel Committee.
Unfortunately.
And I would like to know if there is a procedure by which we could recant a Nobel Prize that was given to the president of this country and offer it to you.
No. The Peace Prize, when Norway and Sweden separated in 1905, we unfortunately gave this Peace Prize to Norway. And that's why they are doing these mistakes. Then the second, in earth science, we don't have a Nobel Prize. And that was because our very, very great scientists, there were two to choose between, but it was probably Dyer who invented the Varkroner. But one of the, or Backlund, there were two of them. One of them had an affair with Nobel's wife, girlfriend. So it is written into this law. This should be that and that subject, but not geology. So geoscience have no.
So now we know why geology is not a Nobel Prize. I can't believe how much I've enjoyed the last 2 days. So far, all the speakers have been wonderful. This has been a wonderful panel. Once in a while, if you want to see what I have to say about things, take a look at junkscience.com. Thank you for your attendance and your participation, and thank the panel.